So I did some, I don't know, finagling on GeoGebra here while I was on pause. And here's what I did. I did a little calculation. So h divided by I, which was this length, this altitude divided by that altitude, and I got whatever my scale factor was. See that? I can move that around. And then I tried to put it on the screen. I know there's a way to get text in front of that 3.1 number. It's like magically just, you know, appearing here. But I couldn't figure it out. Maybe somebody can figure it out for me and tell me how do I get like h divided by I right in front of this so people know what's going on here. This number is the altitude here divided by that altitude. You can see that it's the same as the scale factor, right? Would this work for angle bisectors or for medians? Would it be in the same ratio? Let's try one more, and this time let's do angle bisectors. Okay, the medians, you know, if we can get the angle bisectors to work, maybe you'll believe me that it works for medians as well. Okay, so I need to do a little hiding, right? So let's see, show hide object. I wanna hide my altitudes in here so that you can't see them. Hopefully that's doing it. Let's see here. I don't know. We'll see here in just a second. So if I go, there it goes. Okay, so it's gone. Or not really gone, but it's hidden, right? So I'd like to hide these points too because I don't want that to be confusing. And I said I was going to make the angle bisector. So we need to go down to construct again, and then we need to find angle bisector. And let's do angle bisector for B. So if I go C, B, A, okay, and then if I go up above and I do the one up above, let's see here, I need to go to move because I can't see the thing, and I'm going to do B prime, right? So I go, let's see, construct again. Where is construct? Construct. Did I pass it? I did, didn't I? So here we go, angle bisector, and I'm going to do the same thing, 1, 2, 3, okay? And then, let's see, I want to do a little hiding again because I don't want to see the angle bisector go on forever. I would like to just, you know, find that point and then connect it. Oh, that's right. Now that I'd say that, I need to find the point before I hide it. Otherwise, I won't be able to find that special point. Now we're ready to hide. So let's hide the objects. Here we go. 1, 2. And then let's go back in and construct the segment. So that's down here in lines. And I go 1, 2, and then 1, 2. Okay, let's measure those. Well, actually, I mean, they would be in the measurement already. I don't probably need to measure it. That's like an extra step. So let's go over to algebra, and I think that's an L. Yeah, L and M. My eyes are looking over here, right? And so let's do L divided by M. L divided by M. And what's that come out to be? 3.7. Now notice that 3.7 scale factor, right? So let's move the scale factor and see, does the angle bisector here divided by the angle bisector in the original triangle always equal the scale factor? It does. So pay attention to that today. You know, in your notes, you're going to be given like a couple altitudes. They'll tell you the triangles are similar, and you're going to have to set up a scale factor and solve that proportion, right? So, you know, I don't know if you want to like maybe put down some numbers here, and let's make this easier. Let's say this is like 3, a scale factor of 3, because we could have moved it to 3 on GeoGebra, right? And let's say this down here is too long, right? Well, you could say, okay, well, it's just 3 times bigger in this triangle, so this altitude is 6. Now you might say, okay, it's not going to be that easy, Nelson. How do we do this? Well, you're going to be given something like, okay, this side over here is 12 long, this side down here is 4 long. So you're going to have to figure out the scale factor first. You're going to have to go 12 divided by 4. That's going to tell you a scale factor of 3 because they're probably not going to have this information right there. That's kind of helpful information, isn't it? So I find that first. I take an image divided by a pre-image. That gives me the scale factor. Then I would set it equal to, oh, let's see here. Hold on one sec. I wouldn't have this little part right here, right? So they'd be asking for this length right here. And you'd say, okay, well, and I know you can just look inside here and say, well, hey, that's 3 times bigger, so this one's 3 times bigger. But just in case you're like, hey, I want a system. So you say x over 2, right? and this is like 3 over 1. So what could I do right here to get the x by itself? Right now it's x divided by 2, so I'm going to multiply both sides by 2, right? So we'd have like x over 2 times 2 is equal to 3 over 1 times 2, and these 2's divide to 1, and so now we've got x equals 6. Okay, now I mean these are real easy numbers. Like I said already, you probably wouldn't do this right here. So if you can just put a drawing down in the homework and then find the answer by saying, hey, it's 3 times bigger, that's good enough for me. Now there's one last thing that's a little tricky, and it has to do with angle bisectors. So some kind of separate here. I'm going to put down separate from what we're talking about up there. But it's related. Like if I was going to do a proof, it would involve similar triangles. Okay. But I'm not going to do the proof because I know a lot of people aren't interested in that. So let's put down that triangle again where we had angle B. I'm going to focus on angle B again because I've already got that in my GeoGebra sketch. And I've got an angle bisector in here. So let's draw, so make it clear to everybody that I got an angle bisector because my drawing probably doesn't look very accurate. And then what I want you to do is put some letters on, like this side's going to be side A, this side over here is going to be side B, this side over here is going to be side C, just from this point where the angle bisector hits the side, and this one's going to be D down here. So let's go over to GeoGebra and let's measure those things. So I'm going to zoom the heck out of this so we can just focus on our one triangle that we care about. And I need some measurements. So I'm going to go to my tools and go to measure. Oh, please, 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 let me find that easily. Dilate, did I just pass a measure? Right there. Distance, okay? And I want this segment over here, this side. I said that's important. I want this side right here. Now, ooh, shoot, my letters aren't matching up. See where I've got A here? I don't think that's in my notes like that. And this is C. So I'm going to go back to my notes and I'll fix that for us. And then I think this whole side is B right here. So that could mess us up a little bit. So let's see here. If I go from this point to this point, it should tell me that length. That's HA. And excuse me. And then from C to H, okay, 1.17. Now, before I go back to my notes, let's just do 1.42 divided by 2.49. Okay, so go over to the algebra, and they're going to be right down here. Let's see, that is definitely distance C right there, right? And that is 2.49. I'm just trying to find it in here. So let's see, where are we at here? 2.49. Where is 2.49 at? Maybe it's up above because that's segment C. Let's go up here. Oh boy, it's way up here. See, there it is right there. Okay, but it is called segment C. So down here in my calculations, I can just put down like HA divided by C, I think. I can go HA, I'm going to capitalize it. Let's move this out of the way. See how it says 1.42? That's exactly what I was expecting, right? And then I go divided by 2.49. So, well, but I'm not going to type in 2.49. I'm going to put C down, okay? So I'm taking 1.42 divided by 2.49. Now it's still saying 1.42 here because I think I haven't hit enter yet. As soon as I hit enter, I'm keeping my fingers crossed. I hope that changes to something like, let's see, if I take 1.42 divided by 2.49, that's going to be a little bit less than a half. I mean, 1.42 is, like maybe 0.4 of 2.49. So let's see what happens. Oh, good. Oh, it's a little more than a half. I don't know what I was thinking. So 0.57, all right. Oh, yeah, that's right. Like if this was 2.8 something, 1.4 something would be half of 2.8, but this is less than 2.8, so that makes sense, bigger than 0.5. All right, let's try that again. Let's go CH divided by A. Okay, so let's see what happens there. CH divided by A. What? The same ratio. Now that's kind of shocking, right? That's really shocking in my opinion. So if I go back to my tools and I go up here to move, now I want to get back to algebra so I can see these numbers because they're not projected onto the screen. As I move this around, these ratios change, but they're always equal to each other, right? Do you notice that? That is just crazy. And the proof of it's pretty cool. It involves creating a line that would extend out here and parallel. It's not worth doing the proof right now. So let's not worry about it. And so let's go back to our notes and let's see if we can get something in our notes that might help us out, okay? And it does involve the angle bisector, so let's put down angle bisector. And when you see an angle bisector in just one triangle, it's not like two different triangles, like up here we had two different triangles, right? It's going to be like A over B is equal to C over D, okay? Now in my video 3, I'm going to do a few homework problems. If you need some help doing some homework problems after you've taken notes, please watch video 3. If you're doing okay on the homework, don't bother watching video 3. Thanks for watching, everybody.